Good evening, Pre-Calculus. This is the weekend edition, so you may be looking at this on the 9th, 10th, or 11th. The topic is half-angle IDs. We should be finishing up our power reducing problems. So there were 5 of those, but I did one on the board today on Friday. So you had 4. So on page 415, that was number 29, 31, 33, and 34, and I put those on the video, that actual page from the book yesterday. So if you didn't finish Friday's class, those are due by Monday. So make sure you put that on your plate. Today we're going to take those power reducing formulas. So one of them was sine squared, and we wanted to get rid of the squared, the evil duck, 1 minus 1 so we can rewrite sine squared of an angle as 1 minus cosine of twice that angle divided by 2. And if it was a cosine squared, 1 plus the cosine of 2 times the angle divided by 2. We're going to derive our half-angle identities from these power reducers. So let's see if I can straighten up the video a bit. Is it a little crooked? No, now it's worse. Oh well. You can tilt your head sideways if you need to. Alright. We are then trying to find at the end of our story the sine of half an angle divided by 2, and the cosine of half an angle, which is an angle, divided by 2. So, to do that, I'm going to recognize that it is mathematically sound to take a formula, that's an ID where you have something equal to something, and replace the variable with another variable. So I can say sine squared of b equals 1 minus cosine of 2b over 2, and that would be true. No matter what I put in on this side, as long as I put it in here as well, it is an ID. It is true, it is equal. So I could say sine squared of a star equals 1 minus cosine of 2 star over 2. I could say kitchen sink. Sine squared of the kitchen sink equals 1 minus cosine of twice the kitchen sink divided by 2. So what I'm going to do is put in a over 2 because that's what I want. So I'm going to put sine squared a over 2, which I can change a over 2 as long as I am consistent, and put it over here as well. Alright, so now since I want sine of a over 2, I've got sine squared of a over 2. To get it to what I want it to be, I'm going to take the square root of both sides. That always creates a plus or minus when I do that. So on this side, right, it's creating a plus or minus. The square root of sine squared of a half of angle is sine of a over 2. And I get plus or minus square root of 1 minus cosine, and this 2 over 2 is a 1, so I won't write it, cosine of an a over 2. And that is the trig ID that I'm developing for you tonight. Alright, so keep that, and I'll go over here and do the same thing for cosine squared of a. So I want to replace it with cosine squared of a over 2 equals 1 plus cosine of 2 times a over 2 divided by 2. Alright, so not the whole thing. I'm sorry, I got carried away. Alright, over 2. I don't care about cosine squared of a over 2, I want plain old cosine. So I'm going to take the square root of both sides, creating the plus or minus there on the right, leaving just cosine of a over 2 equals plus or minus square root of 1 minus cosine. This simplifies to a over 2. Alright, so that's my ID for that. I'm not going to develop the tangent one, I'm just going to write it down. So the tangent of a over 2, half of an angle, is equal to 1 minus the cosine of angle A over sine of A. And that's not too hard to develop, but I don't want to really take the time to do it. Or it has another form, and the other form that sometimes is more useful is sine of A over 1 plus cosine A. So this is my ID for half of a tangent of half an angle. Alright, let's use these three to do a problem. So let me see if I can erase the top. And that'll leave us room to do a problem up top here, I think. Now we leave the trig IDs, the new ones, up. Make sure these go in the back where you're collecting all your trig IDs. What number are you up to? Alright, let's see how we can use this. Suppose I want to find the sine of 105. So the sine of 105 is a good candidate for sine of A over 2 because I can take a number, divide it by 2, and get 105, and that number is on the unit circle. 105 is not, but can I not rewrite it as sine of 210 divided by 2? So is not 210 divided by 2 the same as 105? It is. So that's when you can use this trig ID, because we know this on the unit circle, A over 2, but we don't know 105. So we're going to write 105 is 210 over 2 plus or minus the square root 1 minus the cosine of A in my formula. This is A, 210. So, and that's over 2. So let's look at the unit circle and see where the cosine of 210, or what is the cosine of 210. So when I do that, I'm going to get negative square root of 3 over 2. So keep going here, plus or minus square root 1 minus, and when I get to the cosine of 210, it's negative square root of 3 over 2. And that's over 2. Alright, clean that up. Alright, we're not going to leave such a mess laying around. So a double negative gives us a positive. And the square root of 3, so 1 positive, the square root of 3 over 2. That's in the numerator, and the 2 is in the denominator. So, as we've been working, let's get the same denominator here. So I'll replace the 1 with a 2 over 2. And now I can write the numerator as 2 plus square root of 3 over the common 2. So that's all in the numerator divided by 2. So how do we clean 2? We have a 2 here, a fraction divided by a fraction. And if I flip the 2 over 1, multiply it by this fraction, I'm going to get the square root of 2 plus square root of 3 over 4. And all that's under the radical. But I do know the square root of 4, it is 2. So I can remove that from the radical, so I'll just do that like this. And so that becomes, under the radical, 2 plus the square root of 3 over 2, which is outside of the radical. And that's as much as I can clean that up, even though it looks a little messy with a radical and a radical, but that's the way it goes. Let's see if that's anywhere close to, on the calculator, which is just a rough approximation with a demonic decimal, but let's check it. If we look at sine of 105 on the calculator, it comes out to 0.9659, I believe. So when I did this on the calculator, I did the square root of 2 plus the square root of 3 under the radical and divided that answer by 2. I got 0.9659. 9659. So they were the same, so this is the correct answer. This is what I'm looking for, except I don't want to leave plus or minus in my answer. I know in the body of the work it does come out to be plus or minus, but look at this problem. The original problem, sine of 105, what quadrant is that? So we have 90 degrees. We don't work in degrees enough now. So it's somewhere in this quadrant, sine of 105. So you can see the sine is the second coordinate. So we go back and then up. So it is, and all students take calculus. So sine is positive in the second quadrant. So we don't have to say plus or minus. We know that it's a plus. So we can remove all symbols there, and that indicates a plus. All right, that's the kind of work that we will be doing on Monday when we use our sine and cosine and tangent of half an angle. All right, that's it. Have a good one. See you on Monday.